the line passes through the points. Okay, the line passes through the points A and B. Find the equation of the line. This one is easy, right? It came out in the test, right? So I think you all know. Okay, so quick one. Okay, quick one. A. Who didn't do question 6? Who didn't do question? All did. Fantastic. Okay, wow, solid. On fire. Okay, so quickly. Okay, question. Stupid. BA is equals to 3 of 1, 1, 1. Okay? Can BA is 1, 1. If you were to find AB, then you will get negative 3 of 1, 1, 1. This will be the direction vector of your line. Okay? So we have this line. We just use any position vector. We know that this is A, negative 2. 2, negative 1, 5. The direction vector of this line is 1, 1, 1. So for direction vector, we can take a scalar multiple. So we have the good habit of always factorizing wherever possible. They all at the back. Take. They all at the back. Take one from Monisha. Take Monisha. So, okay. L, this equals to. For R, remember to put tilde. A lot of you forget to put. R is a vector. So we put. Okay, so this is 2, negative 1, 5 plus lambda 1, 1, 1. Okay, and lambda is real. Remember to put lambda is real because now you learn complex number. You know you have to make sure that your lambda is real. Okay, this is for 6 part 1. Part 2. Why? What's wrong? That's 2. Okay, next one. Find the projection vector of AP onto AL. This is P. This is A. This is L. Your L is none other than R equals to 2, negative 1, 5. If any point of time you are lost, you tell me. Okay. Okay. Anyone don't know how to do 6 part 2? Be honest. Let's be honest. Lambda. You found lambda. Did you get a final answer for the? I didn't solve for lambda. Oh, okay, I know. Monisha, this is what you did, is it? You go and find like that. Oh, okay. Okay, I tell you what's my ON. My ON is equals to 417. Is that what you get? That's what you got. Ricardo, is that what you got? 417. Question 6. Do you do? Part 1 Then just now I say who never do. Huh? Listen I ask question. Okay, so when I ask you all who don't know how to do or who is the same as who never do okay, so then you must tell me. So if a lot of people then I know I go. A lot of people don't know how to do, I go slow. A lot of people know how to do, I go fast. Huh? Okay, can. Thank you. Okay, so A. Okay. And right. Okay, so what I do is I want to find the projection vector of AP onto the line. So remember in the past when we have two vectors A, B, right? And we want to find the projection vector. Okay, what we do is this green portion is none other than A dot B hat bracket B hat. Right? So this means that okay, first we can find what's AP, and I want to find AP. Come again? A cross B projection vector. The A cross here is the vector component perpendicular to the A cross B like that, right? This is A cross B. This part, this one is a vector component of A perpendicular to B. The bottom one is not A cross. The bottom one is A dot B hat. This one, right, is a scalar. B hat, this one is a vector. So we are getting a vector of projection. You look carefully. It's a magnetic. But I'm finding a projection vector. You go to the second last one or the next one. It's a length of projection. This one. I'm finding. Okay. Can Okay. Can Okay. Next. Quiet. So what is AP? AP, right? You will be able to find that AP is none other than OP minus OA. Anyone can find AP? Answer is 2, 6, negative 2. So my question is this, right? Your AP, right, is 2, 6, negative 2. This is a direction vector. Can I take 1, 3, negative 1? Let me ask you, okay, this one, I want to find the projection here, right? This is 2, 6, negative 2. Can I take 1, 3, negative 1 instead? No, very good, you understand, okay, because we're doing projection, we cannot take, okay, very good, okay, very good, okay, this is a point we may want to clarify, and here, AN, as we can find AN, right, AN has the direction vector 1, 1, 1, correct? So, if this is my B, right, then my B hat is none other than 1 square root 3, 1, 1, 1. With me so far? So this is my B hat, this is my green part. So AN, this portion, we want to find AN. AN is none other than the AP dot product with unit vector of dot product of the unit vector of AN, which is 1 over square root 3, 1, 1, 1. Okay, this is the scalar. After that, that's all. Add the 1 square root 3, 1, 1, 1. Okay? Can So AP is just, so with that, factorizing my 1 over square root 3, I put 1 over 3 outside. Okay? AP is none other than 2, 6, negative 2. So 2, 6, negative 2. Dot product with 1, 1, 1. Okay? My scalar outside is here. My vector outside is 1, 1, 1. Okay, so this will give me the scalar. Final answer, I should have 2 of 1, 1, 1. Okay? This is AN. So this is AN. Am I done? No. I'm not done yet, right? Okay, so AN means I have found that this is 1, 1, 2 of 1, 1, 1. I use yellow now. How to find? The question wants us to find, not only that, the question wants us to find the position vector of the foot of the heart is running away. Who's that? Who's one? Okay. One. Hey, run away. Okay. Huh? No, it's not mine. I thought it belongs to you. Oh, not yours. It went down the stairs. I think it went down the stairs. Huh? The one I buy for your mother. It's a joke. Okay. So what we need to find? Huh? Oh, Mr.
Tan say mother. That means mother. Mr. Tan like your mother. Mr. Tan like your mother.
Okay, so we want to find the foot of the perpendicular. So that is actually ON. That's actually ON. So how to find ON? ON here, right? I want to find this ON. Right. So actually ON is just equals to OA plus AN. Easy, right? Easy game. So OA, then it's just 2 negative 1 5 plus 2 2 2 equals to 4 1 7. It's actually very easy, huh? Oh. Then take a while. Okay, then that's done. Okay, so question 7. Okay. Who don't know how to do question 7? FART. 1, 2, 3, 4. 4 out of the. Okay, can. Yeah. The vector equation of the line passing through A, 2, negative 1, 5 is perpendicular and intersects the line. Okay. So remember what I told you just now. Okay, then I say this equation, right, pass through A, 2, negative 1, 5. Okay, is perpendicular to and intersects the line. Okay, so this line here, so let me write a new page. Okay, passes through A, 2, -1, 5, is perpendicular to and intersects another line. This other line here is x minus 3 equals to y minus 1 over 2 equals to z plus 1 over 2. Okay, what can I do? What's the purpose of doing that? Is to
get
directed the parametric form now. So very good. The main idea you know, okay, always the underlying principle is parametric equation for line is the easiest. So that means right, if I look at this, okay, I try to change to parametric form. Yay! Okay, so after that, from here, okay, I think you don't want to change now. I won't show the change part. Okay, solve. Okay, change to parametric form. Answer comes out to be 3, 1, -1 plus. Very good now. Fantastic. Okay, lambda. So after that, from here, what's the next step? What's the next step? Anyone? Very good. Find the point of intersection. Okay, so what I do is I find the point of intersection. Okay, I find the point of intersection. Okay, I need to find the point of intersection. Okay, let's say I call this point M. Okay, anyway, I can re-express this M. Rewrite this M. Since OM lies on line 2, OM. Yes, very good. Okay. Yeah, so since OM lies on line 2, right? We can say that OM is equals to 3 plus lambda, 1 plus 2 lambda, -1 plus 2 lambda for some lambda. Okay, this is a fixed lambda. After that, what do I do? Anyone got any idea? Ricardo? I find OM already now. Okay, very good. You also know that OM lies on line 1. So what does it mean? What does it tell you about AM? We find AM, okay, very good. We find AM. Okay? So AM, if you are lost, you follow me. If I lost, you follow. It's just OM. OM minus OA. OA is what? OA is 2 -1, 5. So what you're going to get is 1 plus lambda. Yes, very good. Ethan, okay.
So how can you say OM lies on line 2? It's just point M lies on there, but how you know that OM is on there?
Oh yes, correct. You're right. Sorry. Since M. Yeah, since M lies on line 2. Okay. Since M lies on line 2. M is position vector. You're right. Okay. Sorry. Thank you. So with that, right? Okay. After I find AM, what do I do? Can I ask Ignatius? What do I do with AM? After I found AM, what do I do? I just tell you two things. AM is a direction vector. 1, 2, 2 is also a direction vector. What do you do? Don't know. You are trying to find M, the foot of perpendicular. Don't know. Stay with me, pay attention. Okay. Don't know. If you are lost, must tell me you are lost. Okay? Okay, yes. What is it? -1. What they are right? Should be 2 plus 2 lambda, right? Oh, sorry. This one. Okay. Huh? Correct. Okay. Ignatius, you follow me? Okay. Lost. Okay. AM, right? Okay, so you see AM, we have found the direction vector for AM, right? So the question tells you that it's perpendicular to line 1, line 2, right? Okay, so AM, this is the idea. We found A, this one is M, this one is your line 2. Your line 2 has a direction vector which is 1, 2, 2. Your AM, so far you have found this AM, okay, is none other than 1 plus lambda, 2 plus 2 lambda, negative 6 plus 2 lambda. Question tell you that they are perpendicular. What do you do? Dot, and then equate to what? 0. Very good. Okay. So this 2 plus 2 lambda, from here, right? I dot product and I get, oh my god. Okay. I dot product equate to 0. What do I solve for? I solve for lambda. After I solve for lambda, what do I find? To get the OM. Very good. Okay, so have a mental picture in your mind. I have a strategy. I know this is what I need to do. This is how I'm going to get there. Okay, so here we just solve. We why? Mic, you got mic? Huh?
Shut up.
I don't have mic. Do I look like I have a mic? Okay. You have it? Now? Oh, never mind. Sorry. No time now. I don't waste time. I'll make sure you all got the maximum time. Okay, so here you solve. What's your lambda? Lambda should be? Anyone? Yes. Oh yeah, Kiho you say. I was waiting for someone else to say. Kiho you you keep quiet first. Okay. You call Mr. Ang? Why you call Mr. Ang? Okay? Can? Okay, so this kind of question very standard. So after that, the magnitude of AM is just equals to. Okay, so yeah, very good. So it's just A over 9, then you square 2 square plus 4 square plus negative 5 square. Which one? With the what? What's the back? Okay, so this is just A over 9 square root 45, which is 8 square root 5 over 3. Okay? So this is for question 7. This is for question 7. Okay, ma? We have Ricardo. Okay. Next one. Question 8. The lines L1. Anyone don't understand question 7? Do you want me to repeat? Let me repeat. Miguelaba? You want me to repeat? Ethan. No, Ethan I look there. Ethan I know. Come on, Ethan Guang De Han. I know. Yeah. Okay. Guang De something. Okay. Yong De. Okay. Okay. So the lines L1 and L2. Question 8, I have the equation. Okay, quick on. Who don't know how to do question 8? Part 1? Part 1, oh, okay. Part 1, I go through quickly. Okay, so part 1, the acute angle between line 1 and z-axis. Okay, this is between two lines. Between these two lines, okay, the question I'm going to ask is, are we going to use cosine or sine? I want to ask Benjamin Sim, do we use cosine or sine? Huh? Come again? Huh? Sine or cosine? You said sine? Huh? Huh? Between L1 and the XZ axis, cosine. Are you sure cosine? Cosine. Control a bit. I know Valentine's Day, don't get so excited. Okay. Okay, so this is part 1. Okay, part 2. Ignatius. Talk, pay attention, you keep talking. Lecture also you talk, here also you talk. Define the position vector of the full of the perpendicular end from the origin to line 1. Find the position vector of the full of the perpendicular end from the origin to line 1. Same issue. Origin towards line 1. So this is 0, 0, 0. Line 1. This is the vector n. Correct? Your line 1 equation follows this. Is nothing but negative 8, 5, negative 1 plus lambda. Okay? I want to find n. First idea, what do I do? Since ON, first step, let me ask Birong Xuan, what's the first step? I want to find n. What do I do? Perfect, so smart. Okay. Since ON lies on line 1, ON can be expressed as negative 8 plus 2 lambda, 5 minus 2 lambda. Huh? Oh, yeah, sorry. Keep writing wrong, I don't know why. Back. Okay. Oh, yeah, wrong. Okay, with that, what's the next thing I find? What's the next thing I find? What do I do?
Intersection point.
Okay, ON, is it a position vector?
Yeah.
Is it a direction vector?
Yeah.
In this case, yes, it is, right? We can say that the direction vector, because minus the origin, the origin. Okay, so it's actually just negative 8 plus 2 lambda, 5. Very confused, Who's confused? Confused, Huh? What? Okay. So with that, right? What is it? You tell me what they say later. That's quite funny. Okay, can solving this, what's your lambda? Okay, can I ask Choi Yu Hao to this question? What's your lambda? Lambda should be equals to, fantastic, lambda equals to 3. Okay, with that, you find your ON. It's just equals to negative 8 plus 2 times of 3, 5 minus 2 times of 3, negative 1 plus 3. Okay, so it just equals to negative 2, negative 1, 2. Okay, can some nitty-gritty calculations I speed up, but I think you are able to handle, so if you don't know how to do, then let's go back and walk through the calculation. Okay? Yes. Oh, then not. No, not correct. Not correct. Could be some. Yeah, then could be not correct. Then not correct. Yeah, this one, it's a point essential. It's particular one. It's particular. Okay. Next one. Good thing. Find the point of intersection of line 1 and line 2. Okay. Find the point of intersection of line 1 and line 2. So it's not difficult. Okay, so with that, right, how do we find the okay? Yeah. Okay, so correct. So with that, right, quickly we know what's the equation for the first one.
X plus 8 over 2.
Okay, for this, right, what do we do with this? Change to parametric. Very good. Change to parametric. Can I ask Mingalaba to give me the parametric equation of this? Huh? Okay now. Never mind, it's okay. Then after that, this one, okay, so it's the second one, okay. So after that, I want to find this is my line 1, right? I want to find the line 2. Where's my line 2? Oh, this is line 2, okay? So this is my line 2, this is line 1, okay? I want to find the point intersection. So very quickly, I write it off. Question 8, part 3. My line 1 looks like that. This is my line 1. Stay with me. Kiho, stop letting Ignatius talk to you. If he talk to you, just ignore him and say you. Huh? Wow, you're ventriloquist. Okay. 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 So from here, if they intersect, what does the point of intersection fulfill? It must fulfill the equation of line 1, fulfill the equation of line 2. That means, right? That means what? We equate the x components, we equate the y components, we equate the z components. Okay? Yeah. Yalla. Okay? At the point of intersection, okay, so from here, right, very easy, we just solve. Okay, so just take any two equations and solve simultaneously. Alright, you are able to get can you tell me what you get for your lambda and alpha? Lambda is -3/2. Lambda is -1/2. Okay, very good. So what's the point of intersection? What's the answer? Benjamin, what's the answer for point P, the point intersection? Very good. Anyone don't know how I got this? What do you mean? Yes. But when you find alpha and you find lambda, you need to check that it satisfies all 3 equations. So you have to check for all 3. So usually when we solve, right, we take 2 equations to solve, right? But it may not fulfill the third one. We can take any 2 equations you solve, you get us alpha and lambda, but we must check it fulfill the third one. Otherwise, it may be like no solution. It can be skew lines. Huh? Yes. You have to because a lot of times when we solve simultaneous equation, there are 3 here, right? We just take 2 and solve. But we take 2 and solve, how do we know that it satisfies the third one? So we have to check that it satisfies the third one. Okay, then you will know that it is indeed a point intersection. It may not be like skew lines or not intersecting. Okay, so you must find lambda and alpha. Then you start with the third one, and you check that it also fulfills the third equation. Left side, right side. Sorry? No, I didn't show it, but I think you can do it. You also do it. Because here in this case, right, they already told you it is the point of intersection. But if they ask you a question like this, check or determine if any point of intersection between line 1 and line 2, then what must you do? You must check that indeed the lambda and alpha are unique values. You all understand what I mean? Yes. Okay, you must check that the lambda and alpha are unique. A lot of times people will do this. Check if got any point of intersection, right? Okay, take any 2, maybe I take the first 2, alpha, lambda, answer come out, but it doesn't satisfy the third one. Okay, then it's straight away, the first 2 you say, still got point of intersection, but may not have. You must check everything. Okay? This is for question 8, part 3. Then, next. Find a vector equation of the reflection of line 2 in the line 1. Okay. Usually, this is a a new type of question. This is a new type of question. Okay. Okay, our reflection is when you do reflection, it is better that you draw it out. Okay. Okay, in the line L1. What does it mean? Just means reflect. Okay, just means reflect. Okay. So line 2 in the line L1, right? This is your line 2. Okay. So we were thinking about this, then we say want to draw in the line L1. Okay, is it correct? We want to reflect this about this, right? Is it the right way to draw? Let's look at the question again. Does L1 and L2 intersect? Yes. Oh, then is this diagram correct?
Yeah.
Okay, so yeah, but maybe out of the foolscap paper, so maybe I draw like that. How about that? Okay, so what is this point? Very good. Well done, Ignatius. What's the answer again? 9.
Negative 9, 6, negative 1/5.
Negative 3/2. Okay. Then this is my line 2. Okay. Then for line 2, right? Okay, so what else? Okay. Okay, so you see, let's say I call this the reflection. The reflection will look something like that. Okay? Okay. Stupid. Then what you put there? Okay. Then let me ask you, if you check your line 2, can you name, okay, line 2, I say again, line 2, it looks like that, right? Okay, I want you to think about part 2. Okay, tell me one position vector that lies on line 2. And, okay, can you give me one more? Yes, very good, origin. Okay, so this is the origin that lies on. 看到吗? This right, 16你看 this right, this is the same as 0, 0, 0. Yeah, lor. Okay, so this is something people don't see. Okay, so here right, what was in part 2? Part 2 asks us to find the position vector of the foot of the perpendicular from the point, okay, n, from the origin to line 1. So n, as we have found, point n, okay, negative 2, negative 1, 2. Okay, so there seems to be some sort of a relationship here. Okay, now next, suppose what will this be, this point? What will be this point? Given that this is parallel, okay, let's say you can see, okay, can you see this one is the same line, right? This is 90 degree, right? So this will be 90. So this is a straight line, right? Can I say this is a straight line?
Yes.
Let's say I call this maybe n prime. Okay, and this is O. On is equals to negative 2, negative 1, 2. What is On prime?
2 negative. Wait. Lambda for. Lambda for. No, negative for.
No, negative 2, 4. You cannot just double it. Wait, it's only on the axis. You get lambda.
What's the answer? 4 negative 兩成
4 negative 2 4.
啊
Negative 4 negative.
Oh yes, one try to.
which one?
Because this is going down one here, what, don't
Which theorem is the midpoint theorem?
Okay, I'm trying to find the green color point. Okay, look here.
You have to use midpoint theorem.
Huh?
I just use Mitchell theorem.
You don't need to use, only use in this case. Okay. OM n prime. One more time. Okay, guys. Okay, so it's a bit challenging. Okay, I repeat again. Okay, I repeat again. I repeat again. Okay, just okay. Stay with me. Okay, I repeat again. Very closely. Okay, this is line 1. Line 1, right? What was the equation?
R
Okay, lambda is real. The point A is the point. Where's the point? Okay, so there's a point intersection. Correct. This one is L2. What's the point intersection? Point intersection is 9, negative 9, 6, negative 3 over 2. Okay? Line 2, right, follows the equation 6, negative 4, 1. Therefore, can I say it contains the origin? Origin is here, right? Okay. What is the foot of the perpendicular from the origin to line 1? Is n, right? Correct? So what is n? N is, as we have found in part 2, is negative 2, negative 1, 2. Follow me so far? Follow me so far? This reflection, okay, so let's say this is O, right? I want to find the reflection of O about the line L1. So O is here. Let me call it, maybe I shouldn't use O, so or O prime. This n, right? Let's say I call this line that's being reflected. Okay. Okay, this is the reflection of line 2 about line 1. Why? Why are you laughing? Why are you laughing? Tell me the truth. Why are you laughing?
I have fallen
You're falling asleep. ON. Okay? ON. They say this is n prime. Can you all see actually ON prime is the same as 2 times of ON? Can you all see? Huh? Can you see just times 2? Because it's the origin. And also this is one straight line. This is one straight line. Or only because it's origin. Only because it's origin. I can see the same difference. Okay. Okay, so the trick here is this. We need to find 2 points. So here we want to find the equation of this line. I need 2 points. I have 1 point. I need 1 more point, correct? Where do I get this another point? I get it from the origin. So this n prime, right, is equals to negative 4, negative 2, 4. Because can I say this distance the same? Because of reflection, right? I go to the mirror, I stand 10 meters from the mirror, my image also 10 meters from the plane, right? Also, this is n prime. Which one? Because in the previous question, right, the origin was somewhere else. Can you see, in this question, the origin is here. So, no, actually different question, different approach. This one, right? The other question, the origin is somewhere else. And then all 3 of them, right, are points. But in this case, right, your origin is just here. So we don't have to use Rachel theorem. So the origin is just here. OM, right? OM prime is just here. 1 time, 2 times. Okay, because the distance is the same. Can you see? The distance is the same. Okay, can I say these 2 vectors are equal? Can I say 2 vectors are equal? Okay, the magnitude of the vectors are the same. Can, right? Because it's a reflection. It's a reflection. So the distance here and this here is the same. The magnitude here and the magnitude is the same. ON is equal to NN prime. Okay? That's why I can say ON prime is negative 4, negative 2 and 4. So I have this. Can I find the equation of line 2? Yes, stay with me.
Yes.
Okay? So from this, you find the equation of the reflection. Okay? And your final answer should be very quickly. Let me write. Negative 9, 6, negative 1.5 plus gamma, negative 10, 16, negative 11. Okay? This is for the reflection. Okay? This is gamma.